A block of mass 10 kilograms starts sliding on a surface with an initial velocity 9.8 meter per second. The coefficient of friction is 0.5. The distance covered by the block before coming to a very, very simple question. However, I would like to maintain the same, steps and solution here. So solving the question here. So we have first we'll visualize the given scenario. So we have visualization part. Frame of reference. I'll choose a frame of reference to be inertial frame of reference. We have the system, the block, and the flow here. We'll isolate the body, which is this body, right? This body over here. So it is given to us that this body is moving. It is coming up with some velocity 9.8 meter per second. It is traveling like this, and slowly it retards, and then come to rest. Okay, this is what we have. Now, let us identify the various forces acting on it, or maybe let us directly draw the free body diagram of this body here. So what are the forces acting on it? The first force would be the force of gravity, mg. The second force would be normal reaction acting on the block from the surface. And the third force would be the force of friction. Which friction? Specifically here, kinetic friction. Why kinetic? Because the body is sliding, right? And what is the net direction of motion? So if you identify the net direction of motion, the net direction of motion is towards the right. Okay. Now, if we make use of this free body diagram, the net direction of motion is towards the right. So all the forces which are acting towards the right would be taken as positive, and all the forces moving towards the left would be taken as negative. Along the direction of motion would be taken as positive, against the direction of motion would be taken as negative. Now, sigma Fy is equal to 0. Why? Because the object is moving only along the x-axis and there is no motion along the y-axis, which means sigma Fy is equal to 0, and therefore forces acting upwards will be equal to forces acting downwards. Therefore, N is equal to mg. N is equal to mg. Only force acting here is upward is N. The only force acting downwards is mg. Now, when it comes to sigma Fx, means all the forces acting along the x direction. There is only one force acting along the x direction, which will take it as minus Fa. Why? Because this minus indicates it is against the direction of motion. So we have minus mu k into N is equal to ma. What is N? N is mg. So we have minus mu k into mg is equal to ma. M by m is 1. So we have A is equal to minus mu k into g. Now if we apply the equations of motion from this point, initial point A, to final point B, we know that the body is coming into this with the velocity of 9.8 meter per second, and finally it is coming to rest. So final velocity means velocity at B. Initial velocity means velocity at A. So v square minus u square is equal to 2 into as. What is A? We derived it to be minus mu k into g. Into s, that is unknown. Vb is 0. Ub is velocity of A, which is 9.8. So we have minus 9.8 square is equal to 2 into minus 0.5 into 9.8. Negative by negative is 1. So 0.5 into 2 is 1. So 9.8 square by 9.8 is 9.8. Therefore, the displacement is 9.8 meters.